So this one says, which statements are true about sine, cosine, and tangent? And then it talks a lot about the domains and the periods, the amplitudes, and we're supposed to check off the ones that are accurate or true. Okay. So what I'm gonna do is let's graph them and then we'll look at that. So when you do trig functions, we tend to do things in radians in terms of pi. So as I look at option B here, it's talking about the period being 2 pi and stuff like that. So that lets me know that I should change my mode to radians. So I'm just double checking, making sure that I'm in radians. I am, but I'm going to turn the float off. All right. So that's good. So now I'm going to go to y equals, and I'm just going to, let me graph them separately. So I'm going to do sine of x first. Okay, and I'm going to take a little screenshot of that. And one real cool feature about, I say cool, I think it's cool, but I'm a math teacher. But if I click the zoom button, there's a option number 7 is a zoom for trig. And so that's nice because you can see that the range for sine is from 1 to 1. So let's take a screenshot of that. And we'll put that on the slide. And then I'm gonna graph all 3 of these functions. And then we'll look at them and see which statements are true. So the next thing I'm gonna do is cosine. So I'm gonna come right back in here. And gonna go to y equals. If I hit enter, that turns that one off. I want them to be different colors. So I'm going to do cosine here, cosine of x, graph. And cosine looks very similar to sine. That's because they're cofunctions, but we'll talk about that later. Let me take a screenshot of this bad boy. And we'll put that one right down here somewhere. And then lastly, we just want to do tangent. So I'm going to go to this equal sign and turn that off. Boop. And now I'm going to let me do a color that you can kind of see. Let's do blue. I haven't done blue yet. Tangent of x. Graph that. All right, whoops, let's look at the big screen of it. And let me take a screenshot of that one. Okay, so let's zoom in a little bit. This is sine. This is cosine. And this is tangent. So what I want to do is I want to figure out which one of these statements are true. So this one says the domains are all real numbers. Well, are they? When they say the domain is all real numbers, what they're really asking is there any value for x that we cannot include? Well, tangent, because tangent tangent is really equal to sine over sine, or I'm sorry, sine over cosine. Let me write this down. Tangent of x is really equal to sine over cosine. And there are points where cosine equals 0. Whoops. Use the same notation. And so when that happens, it's undefined. That's why we have the vertical asymptotes here. So that one won't work. This is all real numbers. This is all real numbers. But this one is not all real numbers. So this one won't work. Tangent is not all real numbers because when cosine equals 0, it's undefined. So then it tells us the periods. Sine of theta, or I'm sorry, sine of x and cosine of x, the period is 2 pi, and the period of tangent is pi. Well, that's true. That's true. That's something you could just memorize. You don't necessarily. That's true. Well, let me do this. Let's just bubble that bad boy in. That's true. Basically, from here to here is one full period, and it's that occurs at 6.28, which is actually equal to 2 pi. Same thing here. From here to here, this point right here is x equals 6.28, which is 2 times pi. So that's the period. And as we go to tangent from here to here is x equals 3.14, which is just pi. Okay. So that one's true. What's the next one? It says the amplitudes are 1. So amplitude is the distance from the midline. While that's true for sine, right? From here to here is 1. From here to here is 1. That's true for cosine. From here to here is 1. From here to here is 1. However, when you get to tangent, the midline is the x-axis, and that's a completely different shape. So the amplitude on tangent is like a vertical stretch or shrink or compress, right? So that statement's not true. What's the next option? So this one won't work. The graphs of sine of x and cosine of x do not have midlines. No, that's not true. The midline is if you can cut the sinusoidinous wave in half. So they do have midlines. And in this particular case, on the parent functions for sine and cosine, the midline is just the x-axis. So that's the midline. So that one is not true. They do have midlines. Both sine of x and tangent of x are increasing from 0 to half pi, and cosine is decreasing on that. So where is half pi? Well, right here is half pi. This is pi over 2. From here to here is pi over 2. And this is pi over 2. So yeah, that's true, because from here to here, this is increasing. From here to here, this is increasing. And cosine is decreasing. So that last one's true as well. And that's it for that one.